So, and here comes the next presentation, deploying a fault-tolerant PostgreSQL cluster on pacemaker by Kosenkov Igor. Hello dear friends and colleagues, I'm very happy to see all of you here. My name is Igor Kosenkov and I'm working at Postgres Pro company. And today I will show you and I will talk to you about how to deploy a fault-tolerant PostgreSQL cluster on pacemaker and how to do it easily. So our today's talk or workshop will be divided into 3 parts. Part number 1, I will show you how to fine-tune a fault-tolerant PostgreSQL cluster using 3 nodes configuration when you have database on 3 nodes. In part number 2, I will tell you about how to configure cluster in configuration 2+1 when you have 2 databases nodes and 1 electing node. And also I will talk to you about how to use Corosync and pacemaker appliance. And also I will tell you about different problems, about different best practices, and also will share my experience on how to deal with problems that you may come across while using fault-tolerant cluster on pacemaker. So first, I have to tell you that while building cluster on Corosync and pacemaker are divided into 2 groups, correct and incorrect. Correct clusters are clusters with quorum and fencing. What is incorrect cluster? Incorrect cluster are all the rest clusters. That's why I will show you our virtual stand. So on my laptop I have run daemon left word, I have a KVM as a hypervisor, and also I have 3 virtual machines. As I said, in part number 1 we are going to deploy a 3 nodes cluster with RDBMS. So you can see the configuration on the slide. We've got virtual IP that has been allocated so clients could connect to our cluster. And also we've got 3 VMs. I have already installed software required for this demonstration on my VMs. I've got CentOS. Nobody restricts you or forbids you to use other operational systems such as Ubuntu or Debian, Astra Linux, and so on and so forth. Additionally, I have installed Corosync and pacemaker packages, and I have also installed PostgreSQL standard version 11. Preliminary, before you start configuring your cluster, you have to make some settings. So first, our nodes must be resolving by DNS, by local DNS, or in ATC rehost file. So these files must be defined in these nodes, so they had names. In a hypervisor, and we are using a KVM hypervisor, you have to create a user that will have privileges to restart, to switch off virtual machines, or if you are using hardware servers, on these hardware servers you have to have IPMI or ILO cards, and additionally you will have to create a user with switch off and restart on power privileges. Moreover, you have to allow in the connection firewall for hypervisor for the following ports. So on the slide you can see the number of ports that are being used by virtual systems. So last string is IPM ILO is not about virtual machines, it's about hardware servers. Apart from that, you have to allow in the connection firewall between nodes for Corosync 5405 UDP. For Postgres and for management, these are ports 22. Now let's talk about required resources. Among all resources that you can find in pacemaker package, we will have 3 of them. So-called gentleman starter pack. And it will allow us to deploy a fault-tolerant cluster. So these are resources, names, and types. VIP master, which is a virtual IP address, Postgres resources that bear name super PGSQL, and also fencing agent resources that are called fence node according to the node number. Node number 1 for first agent, and so on and so forth. So let's proceed with the console demonstration, and I'm trying to type in commands. First, I want to show you what I have already mentioned, that in the etc host file there are 3 entries that allow us to implement neighboring nodes without using DNS servers. Well, in fact, if we start configuring our cluster, since all packages are pre-installed, but the database has not been initialized, first things first, we need to initialize this database. My user, has rights to do so. So we log in, and we've got sudo rights, and this is the user that we are going to use to perform this demonstration. While initializing our database, I will call a catalog or a folder where SPG data directory is located. -key means that we are going to control control parity, so the database is initialized. And now let's check it out. std11 folder is the folder that is being created when you install Postgres Cross Standard version 11. If you are installing a minor version of Postgres, or vanilla version of Postgres, by default, all data from your PG data of your databases will be located in the Vali PGSQL folder. So the database is launched, it gets connection, but we will stop it for a while. It is to be noted that all the manipulations are being done on one node. Let's say this is our future master. However, master role is conditional, and it will depend on. It will depend. It will switch between the nodes. Now we have to create a replication user. Let's use create user utility. You can also use your database in order to do so, but it's up to you. Since my database is switched off, I will keep this command and then will execute it once I launch my database. Besides, you have to make changes into the configuration file so you can get access to the database. It is PGConf, and also you have to make changes in PostgreSQL.conf global file. I've got some prerequisites, just a few strings that allow me to to get everything into the right condition, and I will show you how to do it. So, here, just to make this demonstration easier, I have allowed all the connections from any users inside our, let's say, internal network. Just in case, I will check what it has copied. Here we go. This is the file that I have copied. Now let me show you the PGConf settings that I have changed. I will just add them to the end. Why so few? Because the rest of the settings that deals with the stable operations like IPsync, number of wall senders, and so on, by default they meet the demands of our replication, of our normal replication operations. And our cluster will work with default settings. The only thing that we are missing is these a few strings. I will add them to the end of the file. PostgreSQL conf. You can use any editor you want, but I love this one. So I've added what I wanted to add. Let's save, then we exit. And next, in order to apply those settings, we have to restart the server. And now we can easily add a new user, because now PGConf corresponds to the condition that will allow us to get access to what we need. We type in a password. Here we go. A user has been created. Let's check. REPL user has appeared, and he has replication permission. Next, do not forget that we have 2 nodes more, and node number 1 database is ready. It will be used for replication, and now, by using base backup utility, we have to copy this database to the rest of 2 nodes. So we head out to node number 2, and we execute base backup command. So I will get back to the slide where I have shown you the configuration that we're going to use. On node number 1, I made all the configuration. Now the database is launched on node 1. It has an IP address 131. So now let's establish a connection.
Так, база данных скопировалась, можно это проверить.
Database was copied and we can check it. So we got it. And then we do the same for node 3. we put here the IP address of the same host, of host number 1. That's right, thank you. So we are done with the database. Now we need to stop to the Postgres at node 1. And one more error, so let's fix it. So we have restored the database. At this point, we probably need to stop. More details: if you install Postgres with meta packages, meta batches, then these meta packages are being installed, but also through CDL system, through service. This service starts by default when the system is started. So since the Postgres start and the stop is run by the cluster soft Corosync pacemaker, then we need to switch off for all 3 nodes the automatic startup of all of this service. I have already switched it off. I will just type this command down here since we have a workshop here, since we learned things. If you look at the status command, we see that the automatic startup is switched off and we can go on. And the same is done for node 2 and node 3. When we are installing the cluster software, the packages we need, there is a new user in the system that is called HA cluster. And then it needs a password wipe, so that in the future these 3 nodes could be authorized using a login and a password of this particular user. I'm just giving here a simple password. So that everything started working right away, so that we didn't make a mistake when we are entering it. The same thing we are repeating for the node 2. We are changing the password here. Now node 3. So now let's go back to the node 1 again. The very first thing that we should do when we are setting the cluster software is to authorize the nodes, since they must be managed and be in the authorized list. To do that, we have commands. So we have a utility to use this with a lot of parameters. The very first thing that we are going to use is the authorization of the nodes in the cluster. And here, using the pcself command, I will list the nodes that will be authorized. I'm also specifying here a user. That I'm going to use to authorize the node. And we have missed the word cluster in here, so we need to type it in here. And we are requesting the password that we have changed, because by default this user doesn't have a password. So now 3 nodes are authorized. Now they can communicate with each other, interact with each other at their level. Let's call our cluster supercluster. And we will start setting it up. I'm typing here the name, supercluster, and I'm also typing in the nodes that are going to be part of our cluster. Just 1 minute. Now, the magic word, setup. Since these nodes on a number of occasions have been aggregated and disintegrated by me, we just need to run the same command using the option force. Now they are exchanging certificates. So the command was a success, and now we are launching the cluster that has no resources yet, no fencing devices or anything. For the time being, we have just made the initial setup for cluster. Using this command, cluster start all, using this, we are launching the whole cluster at any node. Now I can run the commands. After running this particular command, I can run setting commands at any node. So I'm launching it, and now I can, for example, go to the node 2 and to add resources or to change resources. Because now it's a cluster, even though it has no resources as of yet. To control or to see the state of our cluster, there is diagnostic tools and monitoring tools. And we can also see it using the PCS command, typing in cluster status. And we can also see the monitoring tool that is built in this program. It has its own options, so we can show you kind of a snapshot of its state. It can give you the screen that is going to be updated all the time. So that's what you're going to see. You have the screen and you can control and you can see what is going on in the cluster. That's how I'm going to leave it, so that in the future we can see all the events that are happening here. So let's switch back to the node 1 again, and let's continue setting up our cluster. The first thing that we are going to do is we are going to allocate resources. Let me go back to our pictures, our images. So in this list, number 1 is the virtual IP resource. So let's start with it. Let's create it first. I would like to mention here that when you are creating resource, you made some mistakes, some errors. For example, you already got a resource. Then you have 2 ways to fix this. For example, the wrong password, or you gave 192 or 2 times in your IP address. There are 2 ways. First, you delete resource using the PCS command, PCS delete, or you can, with the resource that is already created, you can update this resource, you can edit this resource to, if I make another mistake, I will show you how it works. So here we are creating a resource, we call it the master, we then define its type, because other than the name, each resource should have a type. And we also define here necessary attributes of this resource. So let's go back again to this picture of ours. Virtual IP has the value of 134. So that's what I'm putting down here. And we also should define the network interface that this IP address is going to be attached to. It means that you can set your system up in a more flexible way. You can have a number of network interfaces. One of them could be used to communicate with the external environment, the other one for communication inside the clusters. So there is a certain variation with this option. Interface of this virtual machine has a name of usernet 0. So the next attribute is the mask. And next I'm putting down meta attributes. For example, I'm putting down here that the threshold of migration is 0. It means that in case if there is some kind of failure or crash, so this resource is not going to be moved. It will stay within the node. It will be reinitialized in the node where it was originally launched. Next we have this word op. It means operation or operator. All the resources in Corosync and pacemaker, they have 3 standard functions: start, stop, and monitoring. Usually you don't have to specify additionally any timeouts or how should they behave if during a certain amount of time this resource is not responding. But as of now, I will just put it down fully, even those the values that are given by default, so that we knew that we can be flexible with changing it, like timeouts and so on and so forth. So, for example, operation monitor. "60s" means 60 seconds. So interval is the query interval. It's obvious. If there is some failure, we put here down that it should try to restart the monitor. The next thing, the next action is we are defining timeouts. Here we don't have to do this. I'm not saying anything not because I don't have anything to say, just because I'm afraid of making a mistake. So once again, let's see if everything's right. And I missed the part what we do if it fails. Now I think we've got everything covered, so we are running the command. Great, so now let's see what we have. Please pay attention to this part here. We have this resource now, and its state is it's stopped. So let's move on then. If you thought that that was the longest line, that's not true. We are going to have a longer line now. We are creating a resource for Postgres. It's code super PGSQL. Its type is PGSQL, and we also define its attributes here, and we define where PG data is, where all the binaries are, where well, what IP address we allocate to it, and we also list nodes here that this PGSQL resource can be deployed to. When we are creating the resource setting, the PGSQL resource, we can define all the paths. I think it's a great advantage because different versions of this path are different and they vary. It could be vanilla, it could be Postgres Pro version. You can set them up for particular clusters, for particular binaries and PG data directories.
So next parameter is what replication we will be using in this cluster. Surely we need synchronous replication. Next parameter tells what nodes contain database and what nodes we're going to switch to just in case. Since we have a 3 nodes cluster, we are going to list all 3 nodes. Master IP parameter. Here you can find parameters that we are going to add to file recovery conf file that will be built dynamically once the cluster is started. So we're not doing this manually. A Corosync pacemaker will do it instead. If you will, you can specify a port that will be different from a standard one. And in primary conf.Info parameter, let me just end it. We specify password for replication user. This is a password that I typed in when I was creating a replication user. Here I specify rep user parameter and a username. Yeah, I see there are some typos. So actually you can avoid this parenthesis, but let's just use it just to make it consistent. Of course we need PCS. Let's take another look at this. Okay, you've checked it. Is it okay? Enter. So what happened? We've got another resource. So until we add fencing resources to our cluster, it will never start. So this is the rule. If we are reluctant or if we are making an incorrect cluster, we don't want fencing resources to be in there during the setup. So we can find a problem. If we don't need some appliances, we can just switch them off. You've got this option. Our resources can have one state, let's say master, or multi-state like master-slave. So in this command, we have to say that our resource super PGSQL has a multi-state. Which means on one node, this resource will act as a master. On other nodes, the same resource will act as a slave. So if you need any comments on it, just give me a sec. I'm sorry. This one? Clone Max 3. This one? It's this man. Okay, max 1, enter. Got it. So what has changed? As I said before, this resource has now two states, master and slave. And this node has not been started and will never be, because now we proceed to fencing agent settings. The list of all fencing agents can be found by using Stoney's list. Since we are using KVM, in this list we will use the fence version agent. If you're using VMware, you can use fence VMware SOAP or fence VMware REST. In one case, you will make a call through commands. When you are calling a hypervisor, in this case, you are using a call for port 443. As I said, when it comes to hardware servers, we've got ILO management system, and if it's an IPMI, we've got fancy IPMI LAN for VMware. It is to control hardware service through hardware cards. And also we've got VirtualBox somewhere in there. If you have forgotten some options to specify for your fencing agent, you can use describe command and specify your fencing name. It will give you just a short reference. I'll show you how to do it. So here is the list of all options, and there are even some short descriptions. Okay, now let's set up agents. Before setting fencing, we have to make sure that it works, and you have to do it manually. You have to check the chain between operating system and virtual machine, network, hypervisor, rights, whether you have enough privileges. So that is why, before you proceed to step number 2, I recommend you to use the following command just to check the status. If everything is okay, everything works fine, and everything will work fine. Here we specify a hypervisor IP address, number 1. Login of a super user. Well, not a super user, but a user that we have created. A password, secret password for sure. We define what node status we want to get. So this is the node that we are currently on, node number 1. And of course, we will have to use sudo. So next -o command is what we want to do, to take a list of all machines or just to check their status. I'm going to use this command just to check the status of the node. Hypervisor told us that node 1 machine is active. You can get a list of all machines. You just remove a specific name of a machine. And here is the list of all machines running on this particular hypervisor. So by doing so, we have checked that everything works fine, connection is there, and we can finally create fencing resources. Now we create a fencing resource for node 1. We will call it fence underscore node 1. Fence node 1, just as we wanted, just as we needed. Type of this resource will be fence version. Next we define our configuration parameters. So here we specify in a particular node or a list of nodes that will be isolated or fenced. Since we create this resource to isolate or to switch off node 1, we type just node 1. And next you indicate parameters that we are using to check the connection between a VM and a hypervisor. So this is our hypervisor IP address. We are using sudo. So here we specify what we are currently doing. We are going to use this resource to reboot. So this is just a default value. I have shown this to you so you could have an idea what you can do just to switch off a machine. But reboot is basically enough. And then a monitor parameter. This resource monitor parameter. So we will get back to this parameter once again when I will be talking to you about troubleshooting and frequently asked questions and some best recommended settings when you're using this cluster configuration in production mode. So our cluster has been activated. It launched because it sees a fencing resource. You can just avoid watching at this because it does some stuff. Most importantly is that we now have a resource that has been appeared, it has been launched on node 2. In order to speed up the process and to avoid typing this once again, I will just copy and paste the same command, but with a new value. And I'm going to do the same thing for node 3. So everything is successful. Fencing agent works not on node 1, but sometimes it happens that a fencing agent for node 1 is activated on node 1. Next, we're going to perform a couple of commands just to avoid such situations. Why we should avoid such situations? Why we shouldn't do this? Because imagine a situation, you've got a cluster with node 1, for instance, and it is isolated in the network. By logic, by pacemaker logic, if node 1 is a master, there will be an immediate command to reboot through hypervisor. But since this resource has been launched on this node and it sees that the node is okay, it will never trigger such a command. To restrict launching resources, fencing resources on the same nodes, we're making a very simple set of commands.
То же самое для второго узла.
The same goes for node number 2 and node number 3. Nothing has changed here because everything just worked out pretty well for us in here. And now we need to unite the resources, the BIP master, and we need to combine it with the resource PGSQL. The idea is that if we have the virtual IP address resource must be at the same node where we have a master. So we are just typing in a number of the magical comments. So we are creating a group and we are adding a master in there. This group that is called the master group, apart from the BIP master, I also add the resource of the super PGSQL master. We got it. Now we need to define the order of the startup in this group. So first we start with Postgres, and then we launch virtual IP address, and vice versa when we downgrade for the standby mode cluster. For standby modes, we have it the other way around. So now we have the order of the promotion, now of promote. Now we have to set the order of the demote. So we are done with the setting up. Let's look at the monitors. So failed a little, so I will minimize, scale it down. The only thing that I'm afraid of that if we minimize the window, it's going to be too small and you won't see anything here. What? To make it larger? The thing is that if I make it larger, then it's not going to fit on the screen. So let me do it this way. I'm going to make it larger, but then I will show you not the CRM monitor. I will just show you the status. I'll show you what I'll do. So that's how it looks. What we see here, we see that master SUBD is launched at node 3. Two nodes, node 1 and node 2 are replicas, and the virtual IP address is running at node 3, so let's see if it's true. Yes, it is true. At node 3 we've got a virtual IP address. We can connect to node 3. We two ways, or using the IP address of node 3 or using the virtual IP address. So let's see the state of replications. What we're interested in now, we are interested in the application name. We're interested in the state of replication and sync state. Well, I don't know, maybe also we could see client address. Our cluster is the no working state, so it has the synchronized replica and unsynchronized replica, so it's fail prone, fail safe, and we're running out of time, so let's not break it and let's move to the setting up of the 2+1 cluster to the next stage. I'm stopping the cluster. So we've got 2 lines here. So we have stopped the cluster, and next we need to delete this cluster. So we use the command destroy. We are deleting it, we are destroying it. And then some steps must be repeated so that we could initialize the cluster once again, but now using the 2+1 configuration. So let's appoint a node 3 as a voting node, and the database will be at the nodes 1 and 2. So now we go back to the start. We repeat everything that we have done. I'm not going to type in the long commands. I will just pass them from the history. And now we are going to the 2+1 cluster. Node 3 is going to be voting node or quorum device, the same virtual IP address. And so you can see at this picture everything is pretty much clear. So let's speed things up a little. So, okay, we got it. We start the cluster. So here we have it with no resources yet. Next, I'm going to take, not to type it all again, I'm going to paste here the command to create the virtual IP address. So we have it here. The only thing is that I should no, it's the similar command. Okay, so we have created resource virtual IP address, so now we see it here. When you are creating PGSQL resource, and in the nodes list, we define only the nodes where it's supposed to be launched. So I'm going to edit what I have already entered, and you will see the changes. We are removing the node 3 from this list because it's a voting node. So now let's see what we've got. So here it is. So I will copy this line of command. And then here we need to change the number of nodes from 3 nodes to 2 nodes. Well, you understand why we do it. I'm creating a group, and then I'm adding VIP master to this group, so everything I've already done before. I set the order of promotion. And we are creating the fencing resources. Without fencing resources, our cluster won't start. The different thing from the previous part is that we are creating the fencing resources only to switch off the node number 1 and number 2. The node number 3, that is a voting node, we don't need to switch that one off. So the cluster is active. And now we need to say that these fencing resources didn't start, as we've said before, weren't launched at their own nodes. We also need to say that since when we are creating PGCQL resource, we defined at which nodes it can start. We don't have to define about each command about the voting node because it's not going to be launched there. anyway. So now I'm about to. So can you see it like this? Here at the node number 2, we have the master, and also the vPre service is running at the node number 2, and node number 1, it's a synchronized replica. And the time that we still have, I will use to tell how we can use the device. So the node number 3 doesn't have to be, we doesn't have to install all the packages of pacemaker at node number 3 if it's a voting. We can say that that's device's quorum, but to do that we need to install packages. At the nodes that are database nodes, so there we need to install packages of Corosync and Q device. They are already installed. I'm just showing you how do commands to install them look like. And as for node number 3, that is going to be a quorum device, we need to install their package. QNED. I'll show you how to spell it.
So it is installed. I suggest that we skip this part on setting up this quorum because we are running out of time. I will just show you what to do next. I want to proceed to part number 3, in which I'm gonna tell you about problems and troubleshooting. I think this is more important than talking about configuration, and it will be just helpful for you. In many times, a well-configured cluster with fencing agents, with quorum, sometimes require additional configuration. So if you are using virtualization, for example VMware, then your node, your hypervisor or something above can be overloaded, and Corosync and pacemaker sometimes call fencing devices status. How it happens? So a virtual machine sends a request through hypervisor to its center, and it says, please show me the state of this machine, whether it is alive or not. And hypervisor response can be quite long, may take some time. It can exceed the timeout that I have shown to you when we were creating a fencing device. In order to avoid any problems, there are two ways. You can either offload this vCenter as an option, just to improve the response time, or you increase the timeout for response. How you can do it? You can use update command, so everything is set up, everything runs, but sometimes you have these small problems. you just have to increase the timeout. It is highlighted with red. You can tackle this question radically. Let's say these errors that you encounter, for example, vCenter didn't respond on time, you can just ignore these errors. So option number 2 is just to ignore these errors. Second group of problems is when you do not have archiving configured in your database and you do not have well recovery configured. In this case, if you have a failure and if the server downtime is too long, wells can go back to archive if you have it, or if you don't have your archive configured and well is in off state, these wells will be just deleted. The solution to this problem is to enable archiving. Second, you specify as an archive mode, as an archive command, pg probackup push or rsync with a checksum. The example that you may find in the documentation when we use cp for these archive commands is not a resilient option. Sometimes it may lead you to very serious problems, because in terms of progress the file has been copied. That's okay, but you don't know how it was copied. Maybe it's just a null file, nobody checked it, maybe it wasn't copied completely. The Postgres just see that the file was copied and it deletes all entries from PG directory. So these recommended utilities check this operation, and it is a more robust copying operation. And second part, when you create a PGSQL resource, you have to specify an additional restore command parameter. This parameter, if for example you run a replica and it wasn't used for a long time and the wells went to archive, you say where to find them. It could be rsync or rcp. It's easier in this way, and correspondingly you will have to set passwordless obtaining of RCP among 3 nodes. Should you have any questions, you're welcome. I'm done, and thank you for your listening. Any questions? Tell me, please. You didn't show us the failover itself and the time of switchover and failover. How pacemaker behaves? Pacemaker behaves excellently. In order to embrace all the questions within these 90 minutes, I had to cut some content down. But if you're interested, I can show you how pacemaker executes failover and switchover. As far as time is concerned, time is not constant. This time can be changed, more or less. So it depends, because for any organization, if your network suffers from long, big latencies, you can face false positives. That's why you can't say that, for example, you have 30 seconds. I just want to tell you that Corosync and Pacemaker is a tool, and you as an admin has to fine-tune this tool for your particular case, for your particular needs. For some cases, 30 seconds is okay. For some cases, it's not. That's clear. But maybe just something to start with. Well, something to start with are default values, and then In Patron, this number wasn't taken out of nothing. It goes from ATCD, that sets within just time lag, and there is no need to cut this down. So in Patron, it's not recommended to have it less. Maybe we've got something at pacemaker. So where is the exchange? What are we exchanging? Where messages go? How do you get information on status Postgres, not of a machine? You know, Corosync keeps a very detailed log. All these checks go to this log. If a node doesn't respond, for example, your timeout, you will see all this information in the log. So all incidents will be found there, and the reasons will be found there too. Like 60,000. Now, like timeout was 60,000 and 1 millisecond. So everything, it was above 60 seconds, and that's why there was a decision to switch over, because the node was dead. You will find it in a log. By using this data, you can increase your values. So, universal answer is you will find your best option as you start using this tool. Can you just briefly compare Petroni and this cluster? So a brief comparison. Petroni and pacemaker solutions. Drawbacks and advantages. Have you attended the previous session? Did you pay attention to this slide? About Corosync and pacemaker and fencing. Well, at Petroni, fencing is implemented through HA's proxy when we just re-forward the traffic. We use keep alive ID and so on. But there are some pitfalls in this pattern. To answer your question, briefly, Corosync has a more robust fencing, because if switch off doesn't happen, because of some network errors, promote will never happen. In Petroni, promote can happen, and you may face two masters, and traffic will go to the recently promoted node. And there is a potential risk. What if the older master remains? What will happen? My question is, just to clarify, you've got a VM. Inside VMs, how many network interfaces you have? Just one? Yes. And one you deploy virtually if needed. One virtual interface, this master IP, is deployed if needed. Yes. This configuration was simplified as much as possible, because this demonstration was just to show you the main features. You can, of course, make this configuration more complicated, add more interfaces, or deploy a second virtual address for replication. So options are different. Can you get back to this cloud? Yep. So at some point of time there was IP address 122.21. Where did it come from? So this is a cluster, and cluster is managed by a virtual environment. So virtual machine acts like a cluster. You can put a hypervisor by the side and then use arrows just to show connection. But it will be too much. But in fact, you are right. I had to put a hypervisor image on this slide. It would be correct. It would be correct. On the previous schema, so when you were writing long commands, you said that sync is a must, but at the end you've got one sync, the second one async. Why did it happen? Okay, I got it. You know, Corosync can operate with two replicas, with two standby nodes in async mode. Here, one node is sync, another node is async. In terms of data integrity, and during failover, just not to avoid data during a synchronous replication, we're using the same parameter rep mode, and we're using async. It means that one replica will be sync for sure. If we can use async. Hello, just wanted to know, if we have archiving enabled, is there any sense to set Maxwell for wall storage? Is there any sense of doing so? This parameter was defined by me for cases when we don't have archiving enabled. If yes, this parameter isn't obligatory. Yes, because qual will be stored in a publicly available location like network storage. But you have to have access to this storage. But it's up to you how to organize it. It wasn't clear about replication slots. So what about replication slots? How to create it? So Corosync and pacemaker are not focusing on this. They just get it from backup logs. You just had to query a replication slot list. Well, you can create them, but how to say it? They are not persistent, they are dynamic. So you can act, you get a replication slot. So replica goes off, replication slot disappears. If you do it purposely, you will have too many replication slots. Well, that's clear. Just you didn't mention this, so maybe they just don't focus on this and they use backup only. Okay. Why using focus on restoring command? Well, as I said, it's when we have a cluster, we have two nodes, and we have election nodes. Something happens with replica. It fails. Pacemaker will switch master into standalone mode. So synchronous standby mads parameters, and it will be null. It will be empty. Master will become async replica mode. And imagine that some time passes, walls that were applied will be deleted. In that case, failed replica, so in this case replication slot was deleted. Yes, it's being deleted. So sometimes this is the obstacle. it doesn't allow you to confidently restore your data. It is dynamic. It appears and it disappears when replica goes on and off. So it was just for restoration of rest command. So it's when it's when a replica breaks up. Yeah. Corosync, does it manage synchronous standby parameter in case of a synchronous replication? Just to avoid master from stopping. Yeah, that's what I mentioned. This is how it happens. Yeah, just to avoid master from freezing, it will switch into async mode. And this is managed by Corosync and pacemaker. So it's like in Petroleum. Exactly. Got it, thank you. What about parameter synchronization across all replicas? Like in Petronia, there is a single editing center that are distributed later on other replicas. Do you have the same? If you're talking about synchronization of DBMS parameters, so by using base backup, I distributed it on node 1 and 2, and what comes next? What happens next when you edit it during operations, when you have to edit parameters? So during operations, you want to change something, some characteristics. Yeah, exactly. Well, you will have to manually distribute these changes, to copy these changes to other nodes, and to make a reload. So you don't have it like automated. If you make any changes to cluster, these parameters will not be automatically copied to other nodes. Are you planning to do so? Ah, you are not a developer, I'm sorry. Well, it's a very important enterprise feature because Petronia has it, and it's cool. Because Petronia keeps an eye on these parameters, their validity. It can highlight all these characteristics. It gives you a hint. If, for example, it cannot do something on its own, or we can't just reload a replica, it highlights it, and you will have to do it to fix it manually by reloading or restarting a replica. But everything is already there. It's very useful.
Is there a switchover option? Well, the pure switchover, there is no such thing, but there is a switchover via failover if you want to switch something like a replica that is synchronized and you want to make it a master, and for example you want to put the current master in maintenance, and then in this case you stop the master and not just by unplugging it, not by unplugging a machine or by something similarly radical. You are just sending a command to PCS cluster to stop at that particular node, for example at the master. Then the cluster at that node will stop, and the pacemaker will react to this, seeing a failure in this, and then it will create a synchronized replica. Your virtual address will be switched to a new master, then you continue doing everything you needed to do on your previous master, and then you run the PCS cluster start. Your previous master is becoming a replica. Now it is interesting, so how do you do that? So like 20 minutes later, for example. What's the obstacle? Well, database is a few terabytes. The pacemaker can work with the picture rewind. Not automatically. If your servers just split on the timeline. No, nothing split on the timeline. Does pacemaker work with PG rewind automatically? No, it doesn't. Okay, only manually. No, there are no automatic actions with the pacemaker. Do you plan to include it? No, we don't. It's a pity. It's a bad thing. Thank you, though. You know, the philosophy here is that something happens, you need to deal with it, not just to trust this to the system for the medical repair or recovery like in Petroni. It's a different approach. So PG Rewind is done manually by an administrator. PG Rewind is not a cure, not a medicine to all the diseases. It doesn't always work. So I would really trust an automatic system like Petroni for doing this, Good evening. Thank you for the workshop. The question is, in the situation when the master breaks down and it's being rebooted by fencing, what happens after it has been rebooted and then it works fine? So it found its cluster. Is it going to become a synchronized replica or what? As it's been said earlier, nothing happening automatically in the cluster. For example, if your fencing agent has rebooted your previous master, you need to do the following, being an administrator. You will need to delete the blocking file that is always there at the master that forbids to restart it automatically or just to start it automatically. You wouldn't do it even manually. You remove the blocking file, that's the step number 1, and then if the timelines split it. No, you will see it right after the start. And then the step number 2 will be starting the cluster at this particular node, PCS cluster start command. And if everything is going fine, if the data is still there, if nothing disastrous happened, then the pacemaker will see that there is this node there, and it will make it a synchronized replica. Thank you.